Alright, you guys, so we are on part 8 of the crupi chainring restoration. I just polished it up. I just want to show you, we just got off the buffer, and you know, it's 60 degrees and our ambient temperature outside is 48. So when you're buffing, it's good to get the part hot, and as warm as possible. Start wiping off all this buffer compound. So I'm going to put the camera down and wipe off as much of this as I can with that microfiber rag, so just bear with me here. Alright, so I want to show you this real quick because you'll never figure it out on your own if I don't tell you. 2 fingers, mother's mag polish, right? I'm trying to hold this, and you just literally hit this thing like this, boom, 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 in the grooves, bam, 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 in there, around the teeth. I'm trying to hold this with one hand, but you get the idea, right? And in case common sense eludes you, the reason why it's important to do it right away when it's warm is because the warmer the disc is, the easier that compound comes off, right? And the reason it needs to come off easy is because anything more than this will scratch this polished surface out. So you need to get all that compound off. And just boiling it in the degreaser won't be enough to actually chisel hard, dried on compound. So as the disc is warm, you get this stuff and you just keep going over and over and over, and this stuff here will actually, the mother's mag polish will cut through that grease and keep it from hardening. So as long as you're constantly running like this, and you just keep doing this and doing this and doing this, and all the areas, all the holes, everything, until all that compound's gone, and then you run it in the degreaser bath. Otherwise you will never remove the compound. And I have explained this a long time ago in like video 1 or 2 or 3 or some shit, that grease compound stuck in those parts will leach out when I anodize it and leave a grease trail up the part where it won't take the color. So it all has to come out. This is the easiest, most efficient way to do it without scratching the part. There's another step after this where we're going to go through and smooth all this polished surface out with another soft sanding disc. So stay tuned for that. I need to get on this though. I'm trying to do this in real time for you, so my explanations are fast because I actually am on a time limit. The colder the disc gets, the harder it is to do, which is why I showed you the temperature difference and why I'm trying to run fast. So stay bear with me. I'll continue when I'm to the point where I should turn it back on. Alright, you guys, this is where we're at. We got this thing buffed out on both sides, polished out, and I'm touching it because there's one more step after this before there's no more touching at all. And you can see that the letters themselves are silver. Everything's anodized nicely, cleaned up. And if the logos weren't so shallow because of all the work I had to do to get the spots out, I would have used a Dremel, and I would have gone in between all these little dips and dots with a Dremel bit. With one of these, I'd have put it on the Dremel and just zzz, and went through, dipped it in mother's mag polished and cleaned it out real quick. But because the logos are so shallow, I can't afford to resand it. If it slips and hits the part and I gotta resand this disc, I'll lose some of my logo. So I couldn't afford to do that. So I just got it and did it by hand and got in there and just went around and used the mother's mag polish to cut out the rest of this. And don't use blue magic in any of this process. The ammonia in the blue magic is so strong that it'll actually hurt anodizing. You can use the blue magic to rub on a fresh anodized part and make it fade. It's so toxic to this process. So when I say use mother's mag polish, that's what I mean. Anyway, now that's done. So how we get all of these buffer lines out and all the buffer marks. If this was going to be polished, I would buff it a little bit cleaner than that. But this is going to be an anodized part, so I'm going to use the translucent effect of the anodized color to actually hide a lot of those swirls. I'll blend it, and this is how you do that. Remember, if it was polished, I would be making this surface much more clean. And I would use a flat piece of this stuff right here, and I'd go back and forth in one direction with the grain of the buffer wheel itself, and that would buff it down to almost a mirror finish. But since I'm using the anodizing and this part is sacrificial, I'm not going to spend a lot of time. I'm going to put the round thing on my my DeWalt, and I'm just going to spin it, and that will buff all those marks out and give it a nice, clean, even, how do you want to say, swirl, but not quite, because this is fabric, you know what I mean? That's not a disc, that's a fabric cloth. It's a 3000 grit, you know? And then I'll do 5,000 of the same thing afterwards, and it'll take it down to a mirror finish. But with the anodized layer over it, will hide any of the imperfection swirls that happen. It'll legitimately blend into the part. But if you did it up and down in one motion with the sander, with a flat piece, it would show lines like that right there. You can see those up there. That would show up in the anodizing. So you got to get rid of all that. So I'm going to do that right now. So that's what it is. Mother's mag polish, and just give it to it. And in case you're wondering, why don't I use pneumatic tools or oh this and that, that's because this is the best tool for the job. A lot of guys that are showing you how to do all this stuff on the internet have a warm shop with a heated garage, and they have a big expensive setup. I don't know if you have a big expensive setup or not, then maybe you should get pneumatic tools. But one thing that you don't realize is you go to do this and you got your pneumatic tools, and you go and you order Mother's mag polish and sandpaper, and you're ready to do this job, and all of a sudden you realize that the air blowing off of the pneumatic tools freezes your hand, and you can't wear gloves because they scratch all the parts up. So like electric tools is how you get by without freezing. I'm just saying, like, unless you have a nice setup and a nice place where you can do things, but like a lot of people don't. And I started out with nothing, so I'm just kind of show you. That's why I use the stuff I use, because it's efficient. You know what I mean? It's no frills. It just gets the job done, and in any environment. Same with the anodizing. When I put it on fire, that's because like I'm off grid. You know what I mean? A lot of guys can't. A lot of guys are off grid too, and a lot of guys don't have free power and free this and free that. So like there's ways around a lot of that stuff. So that's why the fire instead of a hot plate is a way to anodize that a lot of people aren't showing you. It's just, I'm showing you how to do it without surprises. There's nothing worse than going into a project and then all of a sudden realizing that the shit you saw on YouTube wasn't the real deal. There's a bunch of stuff they didn't tell you, like the environment they were in and the air tools they were using. They don't tell you all that stuff. So I'm just trying to make it realistic for you. Alright, so this is what we're going to do. And I'm going to only do this for a second because I don't want this shit to fly off. But I should really be more careful here. As a matter of fact, I'm not going to fuck around. So basically, it's going to go on there, boop, and I'm just going to, you know what I mean, to handle it. That's what I'm going to do. Alright, you guys, we got this thing polished out. I really wish my camera was better. I'm running out of daylight here. It's a teachable moment. The only reason this works the way it does is because I used Mother's mag polish to remove the buffer compound, because my anodizing strip or my degreaser will remove the extra Mother's mag polish off this. There's no way you can remove the degreaser off the part without scratching it. It's just nearly impossible. But you can always remove Mother's mag polish with the degreaser solution. So you use the Mother's mag polish in excess to remove the degreaser, or to remove the buffer compound, and then in turn we remove the buffer or the Mother's Magic with the chemical boil in the degreaser. And that's what we're ready for right now. So after this point, it goes into the degreaser. There's no touching it. And I do have to go in there and grind that little hole out again, like I did last time, to remove the anodizing. And so I'll go in there with a little Dremel bit and shave around in there to get back down to raw aluminum. That way I can hang my titanium rod on there, so it gets conductivity. Otherwise, the rod won't make contact with the raw aluminum, because as there's silver, these are all anodized still. The teeth are anodized and all the recessions are anodized, which means logos are all anodized, which means in there is also anodized as well. So I have to make that back down to raw aluminum. I'll do that now. Alright, you guys, we move this operation outside because this could potentially be toxic. I know it's not flammable because if you look in the previous videos, you'll see. I'm not going to explain everything, because if you need to know, I've explained this all before, because this is the second time we've done this to this part, as we're double anodizing it. This is the Caswell degreaser. Should be between 160 and 190 degrees. We were at 160, so we're right on the money. So I'm going to drop it in there now. It's always easier to do less and then come back and do more rather than do a whole bunch. Remember, this is a degreaser, and technically, to be fair, man, the shit, see that teeth hanging out of there? Hold on, let me bend this wire. So I just bowed that wire a little bit to get those teeth dropped below. And this is exactly what I meant by using all the same size tanks for everything. If you had the same water level and the same size tanks, you would never have that issue. If that would have been sticking up an inch more, I would have had to reline that, and then I would have had to touch the part and start this whole degreasing process all over. Thankfully, I got away with just bending the wire a little bit. But back to my point, hold on one second here. This stuff is a degreaser, so technically the buffer compound is a grease, right? So like, you don't want to take all the grease off the buffer compound, because then it'll turn the part back to raw aluminum and you won't have a polished surface no more. All we're trying to do is remove the surface grease, not the actual finish of the metal. So it says to leave it in there for a few, 4 or 5 minutes. I usually put it in there for 2 minutes and then pull it out and see if it passes the water break. And if you don't know what the water break test is, you must know, and you must go back in my video. I'm going to have to do the water break on camera to show you, but at the same time, I'll show you in better detail in the previous videos. So I'm going to take this next to the distilled water now, because as you remember, you go from hot chemical water directly into distilled water, and outside to the tanks inside is too far of a distance. All right, you guys, I'm in here next to the distilled water. I just want to show you real quick, our anodizing tank is at, whoa, shit. Hold on. All right, that was a little much. It's supposed to be at 70 degrees. I turned those heaters up and walked away a little bit, and it went over. I'm trying to get it at like 68. That way the temperature, anyway, I got to get this out. So you pull it out, right into distilled water it goes. And you can already see, looks pretty good actually. I'm going to find out right now. Hold on one second. All right, you guys. So I did it, I went into a water break test. I'm really past the point of talking. It's getting late in the day. I just want to get this part done. And I've explained all this in the past videos, so you're gonna have to watch them now. Part is in there. It's been degreased, passes the water break test. And this time around, when we're anodizing, we do have a little water pump in there to agitate the acid and keep it mixed thoroughly and efficiently with the water. Negative to negative, positive going to the part, titanium, bam. I'm gonna go ahead and turn this rectifier on, get all this situated. I'm gonna run this part, man. All right, even though I've been through all this with everybody before, because this is the second time we've done this, I'm gonna go ahead and do it again. Down to 12 volts. All right, you remember the first time we did this? You remember how high that was? That number was almost double that, because we had more surface area of the part. Now that teeth are already anodized, all the recessions are anodized, the logos, and in all those grooves and everything, that's actual surface area of the part. That's anodized silver, right? That actually is less area, because that part doesn't get anodized. It doesn't accept a color. It won't work over old ano. So that's why the number is so much lower this time around. There's less surface area because we've got it covered in old anodizing already. So that's pretty interesting there. But yeah, it looks like 11.99 volts, that's fine. Looks like it's settling at 1.65 amps. Legit 1.5 hours, 90 minutes, right? 60, 70, 80, 90, yep, 90 minutes. And we're gonna let it cook. And I'm gonna let it sit there, 70 degrees, and I'll be back for, there's no way my phone's gonna sit an hour and a half idle, so it's legit gonna have to be video 9 now, but that'll be the finished video of this part. All right, thanks for tuning in. I hope this is helping. I think it's gonna be all right. You should definitely check back, and you definitely want to go back and check the other videos, because like, you can't miss a step where it won't work.